Hello guys, my name is Balkrishna Srivastava and welcome to Code with PK. So in this video we write C++ code solution for LeetCode Problem number 2, add two numbers. So before we begin, it is a request to please subscribe to my channel. Okay, so this question is basically about adding two numbers and the two numbers are given as linked list. For example, let's discuss the example that is given here. We have 2, 4, 3. So 2, 4, 3 and the next of the last node is null and the other number is 5, 6, 4. 5, 6 and 4 and null. Okay, so the numbers that you are given as linked lists are basically the reverse of the actual numbers. For example, this first linked list represents 342. So the digits 2, 4, 3 are given in reverse order. Similarly, for the next number, the actual number is 4, 6, 5. The digits of this number 5, 6, 4 are given in reverse order, and that is what the question mentions. The digits are stored in reverse order. Okay. Now you have to perform the addition of these two numbers like an actual addition would happen. So considering this case, these are the two numbers that we have. When you add them, digit by digit addition happens from right to left. So we have starting carry equal to 0. 2 plus 5 gives us 7. Carry stays at 0. Then 4 plus 6 gives us 10 plus 0. 0 and now carry becomes 1. 3 plus 4, 7 plus 1, 8. Alright. So this answer, this 807, the actual sum has to be returned as a linked list in reverse order. That is the digits of this number 807 returned as 7, then next is 0, then next is 8, next is null. This is supposed to be returned as answer, which you can check here. Okay, so the idea remains the same. Since the addition of the actual numbers happens from right to left, we can do addition from left to right in our linked list because digits are reversed. Okay, so we can traverse the linked list from left to right, starting from head, then next, and then next, picking up digits, adding them just as we do regular addition. Okay, so when you add 2 and 5, head equal to null. Okay, and when the first digit is 7, you say heads is pointing to 7, the next of which is null. Okay, you added the first digit 7 to our answer that we will return. So this is the sum that we need to return. Okay, head is pointing to 7 right now. First digit generated of the sum after we added these two digits. Okay, so carry is again 0. 4 plus 6, 10. Okay, carry for the next one is 1. So the digit is 0, so it has to come after 7. So this digit 0 gets appended to the end of the linked list. So now the linked list becomes head points to 7, the next of which is 0, the next of which is null. Okay, so when we are appending these digits, these have to be added to the end of the linked list. Okay, then after these two digits, we move on to the next pair of digits 3 and 4 with carry 1. So 3 plus 4, 7 plus 1 gives you 8. Okay, and eventual carry is 0. 8 is appended to the end of the linked list. So now the sum linked list becomes head pointing to 7, the next of which is 0, the next of which is 8, the next of which is null, which is the answer that you have to return. Okay, so the points that you need to remember is first, regular addition, okay, from left to right. Okay, and this is because the actual addition of the digits of two numbers happens from right to left. The digits given to us as linked lists are in reverse order, so we can traverse from left to right and keep adding digits the way they should be. Okay, keeping track of carry. Okay, needless to say. And when I say from left to right traversing the linked list is the very usual standard way, that suppose if these two linked lists are L1 and L2, take a pointer P1 to L1, take a pointer P2 to L2, okay, and then keep moving on to the next nodes. All right. Now there will be a case where the number of nodes in both the linked lists are not equal. For example, if we take a case 1, 2, 3, 4, 5 and we add say 12 to this. Okay, so 5 plus 2, 7, 4 plus 1, 5, and the remaining digits come as it is. Okay, so when you put these two as linked lists, this comes out to be 5, 4, 3, 2, 1 and null. 1, 2, 3, 4, 5 in our question will be represented as this, and then 12 will be represented as 2 and 1 and null. Okay, so when you do your addition, you have 5 plus 2 7, then you have 4 plus 1 5, so 7 and 5, and then the remaining digits 3, 2 and 1 and null, which will be your sum in this case. Okay, so we had P1 pointing to L1, P2 pointing to L2. One of them will run out of nodes. Okay, so either P1, if this is P1, if this is P2, P2 will go to null first before P1. Okay, so second point comes from the first point, that the first point, regular addition happens from left to right as long as both linked lists, both say L1 and L2 have nodes. Okay, the third case is when either of the list has remaining nodes. Okay, so you have to perform addition as you would with the one single list only. For example, in this case, your carry was 0, 5 plus 2 7, carry was 0, 4 plus 1 5, carry was 0, and so on, carry was 0, carry was 0. Okay, we can take another example, say 1 2 3 6 8, and add 53 to this. Okay, carry is 0, 8 plus 3 11, carries 1, 6 plus 5 11, carries 1, so 12, then carry 1 again, 3 plus 1 4, 2 and 1. Okay, so the third point is append digits of P1 or P2, okay, either of which is not null. Okay, I'm going to put this all in a 4-5 line algo, and then you'll understand. Okay, all right. So we saw our regular addition. Okay, we saw the addition where the number of digits are not equal. All right. The final thing is to take care of the carry. For a very classic case, 9999 plus 1. Digits are not equal. 9 plus 1, 10. Carry was 0. Carry is 1. 1 plus 9, 10. Carry is 1. 1 plus 9, 10. Carry is 1. 1 plus 9, 10. And this carry, eventual carry 1 also has to be appended. So if we have this in our question as 9999 and null, suppose L1 is this, and then you have L2 as 1 and null. So 9 plus 1 will give us 0, okay, with carry equal to 1. Okay, so this carry plus 9 will give us 0 again, okay, which makes the next carry as 1 again. 1 plus 9 gives us again 0. The next carry is 1 again. 1 plus 9 gives us 0, and next carry is 1 again. So eventually, if we run out of all digits in entire list and we are left with a carry 1, we have to append 1 to the sum. Okay, so fourth point is append 1 if eventual carry is 1. Okay, all right, 4 major points: regular addition from left to right because numbers are stored in reverse order, and we do this as long as both L1 and L2 have nodes. Then we have this case when either L1 runs out of nodes or L2 runs out of nodes. If both run out of nodes, then we are done with our addition. Okay, just as in this case. Okay, if there are nodes remaining in either L1 or L2, we append the remaining digits of that into the sum. Okay, and then finally we take care of the eventual carry if it is still 1. Append 1 to the end of the linked list if needed. Okay, so if you use these 4 points and you put your algo to work it with the given linked list. Okay, so first you need is sum, okay, empty linked list. So your P1 is head of L1, your P2 is head of L2. Okay, 2 pointers. Okay, and you start with a carry of 0. Okay, sum is your empty linked list. P1 is pointer to head of L1, P2 is pointer to head of L2. Then we start with the first point. We do regular addition from left to right, traversing the linked list, traversing both the linked list together as long as both of them have nodes. So while both of them have nodes, so while P1 and P2, this means while P1 is not equal to null and P2 is not equal to null, okay, we need to find the sum of the individual digits at P1 and P2 nodes. Okay, so find digit, which is basically P1 dot digit, or maybe P1 dot val plus P2 dot val, okay, which is given because the integer inside the node of the linked list is val. Okay, update digit using carry, okay, because there will be a carry in the next iteration from the previous iteration, and update carry as well. Okay, for example, when you add 5 and 2, your carry was 0, your digit is 7, your carry remains 0 for the next iteration. When you do 4 plus 6, your digit is 0 but your carry becomes 1 for the next iteration, and that is what you need to take care. Okay, update carry for the next iteration and use carry to find the digit for this iteration. Okay, and then append digit to sum. Append as in add this node to the end of the sum linked list which starts from empty linked list. All right, then move on to the next nodes. Basically move on to the next digit. Okay, after we add 5 and 2, we move on to 4 and 6, and then we move on to 4 and 3 and 4. And this happens as long as there are digits in both P1 and P2, that is both P1 and P2 are not null. Okay, this so far covers our points 1 and 2. Okay, then basically you check if either P1 or P2 are left with nodes. Okay, so append nodes of P2, append or add. Okay, you have to take care of the carry as well. I'll say add. Okay, add digits of P1 if P1 is not equal to null. Okay, because this condition will break if either P1 is null or P2 is null or both are null. So if P1 was null, we add digits of P1, add digits of P2. Okay, if P2 not equal to null. Okay, this covers our point 3, and eventually, okay, append 1 if eventual carry equal to 1. Okay, we did everything. Okay, we did addition of digits from P1 and P2, and then the remaining digits, and then if the carry is 1, we have to append 1. This thing is your entire algo. Starts here and ends here. Okay, this is what we code. Okay, so when you convert this into code, sum is basically an empty linked list in C++, which is basically saying list node sum is null. P1 and P2 are pointing to head of L1 and L2, so we say list node P1 is equal to L1, list node P2 equal to 2, int carry equal to 0. As long as P1 is not equal to null and P2 is not equal to null, we can get digit as P1 plus dot val plus P2 dot val, basically using arrows, because we'll be in C++, we are using pointers. Then whatever the carry is, we use that to update digit and then update carry as well. Append this digit that we have found to the end of the sum linked list and then move on to the next nodes. Okay, this is as long as P1 and P2 are not null. Then adding digits of P1 will be the same as this process. It will be a while loop again, because you just have to iterate through the remaining digits of P1, taking care of the carry. Alright, so either P1 will be null or P2 will be null. The code will remain the same. We'll just use P1 and P2 in either cases. Okay, and then append 1 if eventual carry is 1. Alright, so I start coding now. So my sum is an empty linked list. Okay, so list node sum is null ptr. Okay, then we have P1 and P2 as pointers to heads of L1 and L2, P1 and P2. So list node P1 is L1, list node P2 is L2. Okay, then we start with carry equal to 0, so int carry equal to 0. Then we do as long as both P1 and P2 are not null. Okay, there are digits in both the lists while P1 and P2. Okay, you can replace this as P1 not equal to null, P2 not equal to null. We find digit. Okay, it was to find digit, which is basically P1 dot val plus P2 dot val. Okay, now you have to update this digit using the carry. Okay, for the first iteration the carry is obviously going to be 0, but this carry is always carried forward. Okay, so you have to take care of the carry. Adding carry to this plus equal to carry. Okay, update digit and carry. Okay, so if digit that you have is greater than 9, then your digit becomes digit %10 and carry becomes 1. Okay, else if the digit was not greater than 9, carry stays at 0. Okay, now append this digit at the end of the linked list. Okay, so we can take a sum head and sum tail. So if sum head equal to null ptr, okay, sum head equal to new list node, okay, and you pass the value which is digit, okay, the next will be set to null pointer, okay, and you set the sum tail as well. So we took this tail for this sum linked list as well, because when you're appending a node to the end of the linked list, you don't want to traverse at the end every time starting from head. You want to keep a pointer to the last node of the linked list and then append the new node at the end of the last node. Okay, that's why taking the tail. So when there is only the first node, tail becomes the head. Else you create a new node, you say list node, new node equal to new list node with the same digit. The next of tail is this new node, and this tail now becomes this new node. All right, and then move the pointers ahead. So p1 equal to p1 dot next and p2 equal to p2 dot next. Okay, so this is your point 1 and 2 when you're adding nodes from both the lists. Okay, then after this either p1 will go to null or p2 will go to p1 will go to null or p2 will go to null or both will go to null. So if there are digits left in p1, if there are digits left in p1, so we say while p1. Okay, we do the same thing, we just don't add the digits from p2, so the entire thing remains the same. Okay, except we don't use p2, so we don't use p2. Okay, we update the carry, we add the carry, we update the carry, update the digit, we add the digit to the end of the sum linked list, and then we don't use p2. Okay, similarly we add digits if there are digits left in p2, so in p2, okay, doing the same thing, except now we don't use p1. So find digit is p2, update digit, update carry, and then p2 equal to p2 dot next. Okay, so this is covering your point 3. Okay, digits of either list 1 or 2. Okay, then append 1 if extra carry is left as 1. So eventually append 1 if carry is equal to 1. So if carry equal to 1, okay, we do the same thing. Okay, this process is being repeated. We'll replace this with a private function, but let me just code and test this first. So digit is 1, digit is 1. Okay, and eventually you have to return some head. Okay, so return some head. All right, so this is your code. Time to test this. Okay, submit this. Okay, beats 100%. Okay, you can optimize the code structure by putting this into a separate function, but then these two go out as data members. So private, I'm not sure if you're used to the object oriented part in C++, but this is how it works. So we can add a private function, void append. So this takes basically a digit, and then we can have a constructor, or we can initialize some head and some tail here. Okay, let them be data members. Okay, some head, some tail. Okay, p1 p2. Okay, void append. So we just put this append part, okay, here. Okay, these are private members, and then digit is the parameter, the argument. So we simply say append and you pass digit and digit. Okay, we don't have to repeat ourselves again and again. Just keep calling the same function. Append, append, and append one in this case. All right. Okay. Took out the repeated code in a separate function. Let me see. I hope we don't get any errors. All right. Code structure is fine as well. Submitting again. Okay, beats 100%. Okay. So this was the solution to your problem, and I hope this was helpful. If there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments. And you can always let me know in the comments if there is a question you want me to solve, or if there's a concept you want me to discuss. So please like this video, subscribe to my channel, and thank you for watching.